2004 A-Level Combined Mathematics Paper 1 question number 7. This video is being done outside of my normal schedule due to the special request of user Mohammed-2007-N2E. If you yourself have any such special request for videos of either past paper questions or lessons, then post them in the comments down below or in the comments of my other videos, and I will most likely check them and make videos similar to this. Now moving on to the question says, let U and V be two parallel lines passing through the points A, which is given by 5, 0, and B, which is given by negative 5, 0 respectively. Now what this means is that if you take the coordinates x equals 5 and y equals 0 and substitute into U, it will satisfy the equation. Similarly, if you take x equals negative 5 and y equals 0, it will satisfy the equation of V. Now moving on from that, the question then says, let the line 4x plus 3y equals 25 meet U at a point P and meet V at a point Q. After that it says, if the length of PQ, the line in between the point P and the point Q, is 5 units, we are asked to show that there are two possibilities for the pair of parallel lines U and V, which means there's some U1 and V1 lines, and there's also another set of lines U2 and V2. This is one possibility for the two parallel lines, and this is another possibility which is distinct from the first possibility of the two parallel lines. So it could either be U1 and V1 or U2 and V2. Both of them work for the conditions that we are given. Now after that, the question says, write down the equations of all four lines determined above. So they're asking us for U1, U2, and also V1 and V2. All four lines. And then it says, find the equations of the diagonals of the parallelogram formed by these four lines. So when we draw these lines, we're going to have U1 and V1, and we're also going to have U2 and V2. And since these two are parallel and these two are also parallel, all four of these form a parallelogram. And in this parallelogram, the diagonals are this line and this line, which they are asking for the equations of. And the question says, also find the area of the above parallelogram. Now to start off with the question, let's go up and try to consider U and V and what kind of facts we can find from the information given that U passes through A, which is 5, 0, and V passes through B, which is negative 5, 0. Now in this graph here, I have drawn the line U, the line V, and the 2 points negative 5, 0 and 5, 0. You can see this point 5, 0 goes through the point U, or rather the line U goes to the point 5, 0, and similarly the line V here goes to the point negative 5, 0. Now these two lines are not necessarily in this direction. They could be in any direction. They could even be like this, or like this or something, but they are definitely parallel, and that's what I've drawn here. I've drawn the lines U and V being parallel to each other. Now if these two lines are parallel, it means that they have the same gradient, and that gradient is therefore common for both of them. So in order to solve this, what I'm going to do first is to let a gradient, let's say M, be the gradient of U and V. So now both of them have the same gradient. In fact, you might want to write, instead of just the gradient, the common gradient. So we have a common gradient of M of U and V. Now considering the 2 points that we have, we know that U must pass through the point 5, 0. That means we have x0 and y0 that we could use in order to draw a line. Now as we know, any line that passes through point x0, y0 is given by y minus y0 equal m times x minus x0, where m is the gradient of the line, y and x are the variables, and y0 and x0 are the coordinates of the known point x0, y0. So according to that, if we consider these two lines U and V, we can see how U passes through the point 5, 0, and therefore U could be given by y minus y0, which is 0, divided by x minus x0, which is 5, so x minus 5 equal m. And rearranging this, of course, we can say U is given by y equals m times x minus 5. Now we can do a similar thing for the line V. Considering the line V, we can see line V passes through negative 5, 0. Therefore, x0 is negative 5 and y0 is 0. And according to that, if we consider V, V is going to be given by y minus y0, which is 0, divided by x minus x0, which is negative 5, equals m. And similarly, if we rearrange this thing, we can see v is given by, I can take this as y equals, and if I take this thing, we have x minus negative 5, which is x plus 5, and therefore taking that to the other side, we can see we get m times x plus 5. So according to this, u is given by y equals m times x minus 5, and v is given by y equals m times x plus 5. Now, given this, we can also find the points P and Q based on the other line, which is the line 4x plus 3y equals 25. Now, considering this line, we can see this line intersects the line U and the line V at the point P and point Q respectively, as given in the question. It intersects mu at P and intersects V at Q. So according to this, the coordinates of P must satisfy both 4x plus 3y equals 25 and the new equation for U, which is the equation y equal m times x minus 5. Similarly, considering the other point Q, the coordinates of Q must satisfy both 4x plus 3y equal 25 and the other equation, which is y equals m times x plus 5. So according to this, we have this line and this line's intersection, which you can find by using the fact that both of these are corresponding to the same exact points to find the coordinates of x and y of P. And similarly, we can use this equation and this equation to find the coordinates of Q. So going down, let's let the coordinates of P be x1, y1, and similarly, let's let Q be x2, y2. And all we need to do in order to find P and Q is to simply substitute x1, y1 into both the equation of U and the equation of this line. And similarly, we need to substitute both x2 and y2 into V and this line, and then treat them as simultaneous equations in order to find x1, y1 and x2, y2. So going down, for P we can say, since P passes through U, we can say U passes through P, since P is on U, the coordinates of P, x1, y1 must satisfy this, and therefore y1 equal m times x1 minus 5. y1 equal m times x1 minus 5. This is going to be equation 1. Now similarly, we can say since P is on the other line, which is 4x plus 3y equals 25, we can say 4x plus 3y equals 25, 4x1 plus 3y1 equal 25. This is equation 2. Now we can combine 1 and 2 by multiplying 1 by 3 times and then taking that 3y and substituting in this equation for 3y. So if we take 1 and multiply by 3, we can do 1 times 3 in order to get 3y1 equal 3m times x1. We can write 3m x1 minus 15 times m, and then we can take this and substitute into 2 and see we're going to get 4x1 plus, and instead of 3y1 we get 3mx1 minus 15m, 3mx1 minus 15m equal 25. And now we can see, if we take this constant term to the other side, 4 plus 3m times x1 is equal to 25 plus 15m. And now finally, dividing both sides by 4 plus 3m, x1 is equal to 25 plus 15m divided by 4 plus 3m. Now from this, in order to find the value of y1, what we're going to do is to take the value of x1 and resubstitute back into equation number 1. And from that we can see we're going to get y1 equal m times x1 minus 5. And therefore, if I go down, I can substitute into 1 and say y1 is going to be equal to m times the value of x1, which is 25 plus 15m divided by 4 plus 3m minus 5. Now simplifying this down, I can take common denominator of 4 plus 3m. And from that I'm going to get m times 25 plus 15m divide by 4 plus 3m, and then I'm going to have minus 5 times 4 plus 3m on top, meaning I'm going to get minus 20 minus 15m on top. Now from this we can see, if I cancel out this plus 15m and minus 15m, we get 25 minus 20, which is 5, times m divided by 4 plus 3m. According to that, y1 is going to be equal to 5 times m divided by 4 plus 3m. And with that, we have found the values of x1 and y1, and hence we have found the coordinates of the point P. Now for point Q, we're going to do the same exact thing. We're going to say point Q is on the lines line V and this line right here, and according to that, the coordinates of the point Q, which are x2, y2, should satisfy line V and should also satisfy this line right here. So going down, we can say, similarly, since Q is on the line V, it must satisfy the line V, which is the line y equals m times x plus 5. So according to that, we must have y2 equal m times x2 plus 5, which is going to be our equation number 3. Now similarly, we can say, since Q is on the other line, the line 4x plus 3y equals 25, it must satisfy this line, and therefore we can say 4x2 plus 3y2 must be equal to 25, which I'm going to call equation number 4. Now from this we can see, if we take equation number 3 and multiply by 3, we're going to get 3y2 equals 3 times m times x2 plus 5, and substituting into 4 we can see we are going to get 4x2 plus, and instead of 3y2 we can put 3 times m times x2 plus 5 equals 25. Now simplifying this down, we can see we have 4x2 here, but we also have 3m times x2, which if I factor out, we're going to get 4 plus 3m times x2, and on the other side we can see we have 25, and if I take this 3m times plus 5, I'm going to get 15m, and if I take this other side, I'm going to have 25 minus 15m. Dividing both sides by 4 plus 3m, I'm going to get x2 equal 25 minus 15m divided by 4 plus 3m. Now going up, we can see this is very similar to the equation we got for x1. However, in x1 this is a plus, but in x2 this term right here is minus. We have 25 minus 15m on top, but for x1 we have 25 plus 15m on top. Now moving on to y2, in order to find y2, what we can do is to take x2 and resubstitute back into equation number 3. So according to that, from 3 we can get y2 equal m times x2 plus 5, which is 25 minus 15m divided by 4 plus 3m plus 5. Now simplifying this down, we can see we get m times, and taking the common denominator of 4 plus 3m, we have divided by 4 plus 3m, and on top we're going to get 25 minus 15m, and then plus 5 times 4 plus 3m, which will be plus 20 plus 15m. Now considering this, we can see the minus 15m and plus 15m cancel, leaving us with 25 plus 20, which will be equal to 45, and therefore on top we have 45 times our m divided by 4 plus 3m. So according to that, y2 is equal to 45m divided by 4 plus 3m. Now with this, we have also found y2 and x2, and therefore we have found the coordinates of the point Q. So with this, we have found the coordinates of P and the coordinates of Q. Now in the question they said, the line PQ has length of 5 units. According to that, we were asked to show that there are two possibilities for the pair of parallel lines U and V. So according to this information, if the line PQ has length of 5 units, then the distance between the point P and the point Q is therefore going to be equal to 5 units. And as we know from the distance formula, if you have 2 points P and Q with coordinates x1, y1 and x2, y2, the distance PQ is going to be equal to the square root of the x distance squared, which will be x2 minus x1 squared, plus the y distance squared, which will be y2 minus y1 squared. Now all we have to do here is to substitute in the length PQ and x2, x1 and y2 and y1 and simplify down, and we will see we are going to get a quadratic equation in terms of m, which will therefore show that there are two values that satisfy an equation, and therefore there are two possible gradients for the two parallel lines, meaning that there are two pairs of parallel lines u and v, u1 v1 and u2 v2. So considering substituting, pq is equal to 5, and therefore on the left hand side we have 5 equals, and on the right hand side I'll make a really big square root, and on the inside here we have x2 minus x1, and x2 is this value 25 minus 15m divided by 4 plus 3m, and x1 is 25 plus 15m divided by 4 plus 3m. Therefore we get on this part here 25 minus 15m divided by 4 plus 3m, which is x2, minus 25 plus 15m divided by 4 plus 3m, whole thing squared in the middle, plus, and then we have y2 minus y1, which I have to also substitute, and going up, if I take this to the left hand side a little bit to have extra space, we have y2 equal 45m divided by 4 plus 3m, and y1 equal 5m divided by 4 plus 3m. Therefore for y2 we get 45m divided by 4 plus 3m minus y1, which is 5m divided by 4 plus 3m, whole thing squared. Now, if we square both sides, we can see on the left hand side we're going to get 25. So we get 25 equals, and on the other side we are going to get this whole thing, which is going to be equal to 25 minus 15m minus 25 minus 15m. So we can see here the 25 minus 25 cancel, and the minus 15m and the other minus 15m added together become minus 30m divided by the common denominator of 4 plus 3m whole thing squared. Now similarly for the other terms we can see 45m minus 5m is 40m, and therefore on top we have 40m divided by the common denominator of 4 plus 3m whole thing squared. So therefore we get 40m divided by 4 plus 3m whole thing squared. Now considering this, we can see on the left hand side we leave the 25 for now, and on the right hand side we have 30m whole thing squared plus 40m whole thing squared with the common denominator of 4 plus 3m whole thing squared. So considering this, we can see we have 4 plus 3m whole thing squared on the denominator, and on top we have 30m squared plus 40m squared, which is 900m squared plus 1600m squared, and as we know this is going to be equal to 2500m squared, which is going to be 50m whole thing squared. So according to that, we can see we're going to get 5 squared on the left hand side equals, and on the right hand side we're going to get 50m divided by 4 plus 3m whole thing squared. And we can do this because 900 plus 1600 is 2500, which is equal to 50 squared. Now given this, we can see if we simplify both sides by taking the square root, we're going to get 50m divided by 4 plus 3m equal to, and since we took the square root of both sides that were already squared, we need to add a plus or minus, and therefore this term is equal to plus or minus 5. Now from this we can see 50m is equal to either 5 times 4 plus 3m, or is equal to 50m equals minus 5 times 4 plus 3m. Now simplifying each of these separately, we can see for the first one we have 50m equals 20 plus 15m. For the second one we have 50m equals minus 20 minus 15m. Now simplifying each of these, we can see on the left hand side we get 50m minus 15m, which is 35m, equal 20, which simplifies down to m equal 20 divided by 35, or 4 divided by 7 times m. So that's one result. Or we can have 50m plus 15m, which is going to be 65m equal negative 20, and dividing both sides we can see m is going to be equal to negative 4 divided by 13 times m. If we divide both sides by 5, we're going to get 13 here, we're going to get 4 here, so therefore we get negative, no, not m rather, that's wrong, negative 4 divided by 13. I don't know how I made the same mistake here as well. It's not m, it's just 4 over 7. So our two results are m equals 4 over 7 and m equals negative 4 over 13. Now, since there are two possible gradients for our two parallel lines u and v, we can have two different values which are going to result in two different sets of lines, u1 and v1, which have gradient of 4 over 7, and u2 and v2, which both have gradient of negative 4 over 13. So with that we can say finally, since there are two possible gradients, we can say there are two possible pairs of lines u comma v, which we'll call, let's say, u1 v1 with, and we'll say gradient 4 over 7, and another set of lines, let's say u2 comma v2 with the other gradient m equals negative 4 over 13. So with this we've established there are two pairs of lines u1 v1 and u2 v2 for 4 lines total, and we can see according to this, for the next part of the question, we need to find the equations of all 4 of these lines according to the values of m equals 4 over 7 and m equals negative 4 over 13. But for now, we are done with the first part of the question, which asks us to show that there are two possibilities for the pairs of parallel lines u and v. Now moving on to the next part of the question, we are asked to write down the equations of all 4 lines determined above. So for this, what we're going to do is to take the two original forms of the line u and the line v, which is u given by y equal m times x minus 5 and v given by y equal m times x plus 5, and we're going to take them down and substitute in separately the two values of m to find u1 v1 and u2 v2. So in general we know a line of the form u is given by y equal m times x minus 5, and the general form of v is given by y equal m times x plus 5. According to this, if we define u1 and u1 to be the lines corresponding to m equals 4 over 7, we can say for m equals 4 over 7, we get u1 given by, and substituting in, we get y equals 4 over 7 times x minus 5, and similarly for v1 we get v1 given by y equals 4 over 7 times x plus 5. Similarly, for the other gradient, which is m equals negative 4 over 13, we get for m equals negative 4 over 13, the two equations u2 and v2, where u2 is given by y equals negative 4 over 13 times x minus 5, and v2 is given by y equals negative 4 over 13 times x plus 5. Now, with this, we are actually done with finding the equations of u1 v1 and u2 v2, the 4 lines that we wanted. In this case, I know that they are not in the form y equals mx plus c or the form ax plus by plus c equals 0. However, we were not asked to find any particular forms. We were just asked to find the 4 equations of the 4 lines determined above. So with that, we are done with that part of the question and can now move on to this part of the question, which says find the equations of the diagonals of the parallelogram formed by these 4 lines. Now what they're talking about here is the fact that since u1 and v1 are parallel and u2 and v2 are parallel in a different direction, we're going to have two parallel lines like this, another two like this, which is going to create a parallelogram as we can see here. There's going to be a parallelogram created like this. Now in this parallelogram, they are asking us to find the equations of the two diagonals of it, which are this line here and this line here. So they're asking us for the equations of these two lines. Now to find these two equations, we need to find the 4 intersection points, which are this point, this point, this point, and this point, which can be found by the fact that this point comes from the intersection of these two lines, and so on and so forth for the other 4 points. So for this, what we're going to be doing is to be plotting all 4 lines u1, v1 and u2 and v2 in a separate diagram like this, and using that, we're going to find the intersection points of all 4 of these lines u1, v1 and u2, v2. So for this, we're going to use the fact that since u was defined to be going through phi comma 0, all lines of the form u, as in u1 and u2, must pass through the point phi comma 0. Similarly, since all lines of the form v must pass through negative phi comma 0, v1 and v2 must both pass through negative phi comma 0. Now considering u1, v1 and u2 and v2, we can see u1 and v1 have the same gradient, which is 407, which is positive, and u2 and v2 have the same gradient, which is negative, and actually smaller in size to the first gradient, which is negative 4/13. According to this, our first graphs of u1 and v1 are going to have positive gradient, and our two graphs of u2 and v2 are going to have negative gradient, which is more shallow than the first gradient of m, because it is 407, and here if we take the absolute value, it is going to be negative 4/13's absolute value, which is 4/13, which is smaller than 407. According to that, if I draw our lines, we're going to have two positive gradients for our first lines, which are going to be positive like this, less than 1 of course, but still positive like so, and we're going to have another set of gradients which are going to be negative, but they're going to be shallower negative of negative 4/13. Therefore, we're going to have lines that look like this, where their gradients are a little bit more shallow. Now for the positive gradients, we're going to have the two lines u1 and v1, where u1 must pass to the point of 5, 0, and therefore we're going to have a line going through 5, 0 here, which is going to be u1. So this line right here is the line u1, and similarly we're going to have the line v1 passing through negative 5, 0. So if this is u1, the line with the same gradient passing through negative 5, 0 must be the line v1, and therefore this line right here is the line v1. So I'm going to mark it as v1. Similarly, for the negative gradient ones, one of them is going to pass through the point 5, 0, and it's going to be u1. So therefore we're going to have u2 being this line right here, passing through 5, 0, and the parallel line to that is going to be this line right here, which is going to be v1, or rather v2, and it's going to pass through the point negative 5, 0. Therefore, the upper line here is the line of u2, and the lower line here is the line of v2. Now considering these four lines, you can see they intersect at 4 points, and out of those 4, we have already found 2 of the points. The 2 points that we already found are of course the points which are negative 5, 0 and 5, 0. So all we need to do is to find the other 2 points. Now for the purpose of this question, I'm going to mark this intersection point here as the point A, this point as the point B, the point down here as the point C, and the point up over here as the point D. Now as it turns out, while in this setup we have the coordinates of the point A and the point B, which we can use to find the equation of the diagonal AB, we actually don't need to find the coordinates of the point C or the point D in order to find the equation of the diagonal CD. The reason for this actually comes from the fact that if you have any parallelogram, the two diagonals of the parallelogram will perfectly intersect and bisect each other at a common point, which will therefore be the midpoint of both of these diagonals. This knowledge actually comes all the way back from O-level times. So if I draw the two diagonals AB, which is already drawn, and the diagonal CD, and we consider AB, the midpoint of AB, which has the coordinates negative 5, 0 and 5, 0 for its endpoints, is going to be the origin 0, 0. We can see that by taking the average of these 2 points. So therefore, the midpoint of AB is going to be the origin 0, 0. Now as we know, ABCD here, or rather ACBD here, is a parallelogram, and therefore if the midpoint of one of its diagonals AB is the origin, the midpoint of the other diagonal must also be the origin O. So according to that, this length is equal to this length, and CD passes through the point 0, 0, which is the center point of the line CD. Now, we can use this information in order to easily find the equation of the line CD. Before we do that, let's first quickly find the equation of the line AB, which is extremely easy to do since we can already see the two coordinates of it are negative 5, 0 and 5, 0, and according to that, the y coordinate hasn't changed at all, while the x coordinate changed from negative 5 to 5, and therefore the diagonal AB trivially has the equation, and we can directly write the equation of AB is given by y equals 0. Since you consider the equation here, since there is 0 change in the y direction for any change in x, we can say the gradient is 0, and therefore the equation must be y equals 0, since our line goes through the y value of 0 for all values of x. So according to that, we've already found one of the equations. The equation of the first diagonal, AB, is y equals 0. Now considering the second diagonal, we can see this diagonal passes through the intersection points of both v2 and u1 and v1 and u2. Now as we know, whenever you have two lines and a third line that pass through the intersection, if this line is, let's say, L1 and the other line is L2, where L1 and L2 of the form ax plus by plus c equals 0, then the third line here, which I'll call L, is given by L1 plus lambda L2, where lambda is some kind of constant. So according to this, if we can find the equations of these two lines, which in our case we could either choose a v1 and u2 or u1 and v2 rather, we could either choose this line and this line or these two lines, in which case I'll choose these two lines here, v1 and u2, and we can find them in the form ax plus by plus c equals 0. Then we can directly substitute into the equation and say that this diagonal here, let's say L, is given by u2 plus lambda v1, where lambda is a constant to be determined. Now considering that, what we can do is to find u2 and v1 in that form and substitute and use the fact that this line must also pass through the origin to finally conclude what the equation of this line is. So for that, we're going to first take this equation and turn them into the form ax plus by plus c equals 0. So taking these down, we can take this one over here, and we can also take v1's equation and simplify both of these down into the form of ax plus by plus c equals 0. So considering the first equation, we can see we could multiply both sides by 13 and get 13y on this side, and consider the minus 4x here, we could take the other side and write 4x plus 13y, and then we would have minus 4 times minus 5, which is plus 20, taken to the other side is minus 20, and therefore we get 4x plus 13y minus 20 equals 0 for the equation of u2. Now similarly for v1, we can see if we take this 7 to the other side, we can get 7y. If we take this 4 times x to the other side, we get minus 4x. So we have minus 4x plus 7y, and then we have 4 times plus 5, which is going to be plus 20. Taken to the other side is going to be minus 20. So we have minus 4x plus 7y minus 20 equals 0. Now according to this, we can say since CD line passes through the intersection of the lines u2, v1, we can say that the CD line is given by u2 plus lambda v1, where lambda is a constant which is an element of the real numbers. Now according to this, we substitute, we can see 4x plus 13y minus 20 plus lambda times the other equation, which is minus 4x plus 7y minus 20 must be equal to 0, and this is the equation of our line CD. Now additional to this, we can also say since the line CD must pass through the origin, which is 0, 0, we can say that substituting x and y as 0 into our equation here must satisfy it. So according to that, we can say since 0, 0 is on CD, as CD is a diagonal, and we need to say the whole equation that we, or rather the whole argument that we had previously is a diagonal of ACBD, and the midpoint of the other diagonal, which is AB, is the point 0, 0. We can say substituting 0, 0 into our equation here will satisfy it, and therefore 4 times x, which is 0, plus 13 times y, which is 0, minus 20 plus lambda times minus 4 times 0 plus 7 times 0 minus 20 is equal to 0. Now simplifying this down, we can see this is 0, leaving us with minus 20 on the outside. So we have minus 20 plus lambda times, and on the inside here we have 0, 0 and minus 20. So plus lambda times minus 20 is equal to 0. Now we can see here, if we divide it by minus 20, we get 1 plus lambda equals 0, and therefore lambda equal negative 1. Now according to this, finally we can substitute back and say CD equation is going to be given by, and we can substitute into here lambda as negative 1. So copying this down, we can see we get 4x plus 13y minus 20 plus lambda, which is negative 1, so minus 1, times 4x plus 7y minus 20 equals 0. And therefore, if we simplify this, we get CD given by 4x minus negative 4x, or 8x plus 13y minus negative plus 7y, which is going to be minus 7y. So we get 13 minus 7, which is going to be equal to 6. So plus 6y, and then minus 20 minus negative 20 is going to be 0 equals 0. And therefore, CD can finally be simplified down to 4x plus 3y equals 0. And therefore, we found the two equations of our two diagonals, and they are diagonal AB given by y equals 0 and diagonal CD given by 4x plus 3y equals 0. And with that, we have solved that part of the question. Now finally, we can move to the last part of the question, which says also find the area of the above parallelogram. Now this last part of the question is actually quite easy, since all we need to do in order to find the area of this parallelogram here is to simply find the vertical height of the point D above the x-axis, aka the y-coordinate of the point D. The reason this is all we need to find here is because if you consider the parallelogram here, since the AB is a diagonal of the parallelogram, the triangles ABD and ABC are both congruent to each other. Therefore, their areas are equal, and therefore, the area of the total parallelogram is equal to double the area of the triangle ABD. Now, considering the triangle ABD, we can see, in to apply half into base into height here, we need the base, which is AB, which you can easily find since we know the two endpoints A and B, and therefore, the only other thing we need is the height, which is going to be equal to the vertical height of the point D above the x-axis, i.e. the y-coordinate of the point D. Therefore, all we need to find here is the y-coordinate of the point D. Now for this, I'm going to go down, I'm going to let the point D be given by, let's say, x3, comma y3. And what we need to find here is the value of y3. So in order to find x3 and y3, what I'm going to do is use the fact that the point D is on the lines v1, u2, and also on the line CD. Now out of these three lines, we only need 2, and therefore I'm going to use the two lines v1 and CD that we just found. So going down, for CD, which is given by 4x plus 3y equals 0, I'm going to say, since D is on CD, the coordinates of D must satisfy it, and therefore 4x3 plus 3y3 is equal to 0. So we can say 4x3 plus 3y3 equals 0, and we can rearrange this, and since we want to find y3, I'm going to try to replace x3s with y3s by rearranging this to get x3 equals, and taking this other side, we can see we get negative 3y3, and then divide by 4, so x3 is equal to negative 3y3, divide by 4, which I'm going to call equation number 5. Now similarly, considering v1 here, if we go up and consider v1, v1 is given by y equals 407 times x plus 5, and therefore we can say, since D is on v1, y3 must be equal to 407 times x3 plus 5, which I'm going to call equation number 6. Now we can combine equation number 5 and equation number 6 in order to find the value of y3. So if we do equation number 5, comma equation number 6, we are going to get y3 equals 407 times the equation of x3, which is negative 3y3 over 4. So negative 3y3 over 4 plus 5. Now simplifying this down, we can see we get 7 times y3. If we take this to the other side, 7y3 equals 4 times negative 3y3 over 4. This and this cancel, leaving us with negative 3y3. And finally, 4 times plus 5, which is going to be plus 20. Now simplifying this down, we can see, taking the minus 3y to the other side, we get plus 10y3 equals 20, and therefore y3 equals 20 divided by 10, which is 2. So according to this, y3 is equal to 2, and therefore the vertical height of the point D above the x-axis is equal to 2. Now according to that, we can apply this and say, in our triangle ABD, not ABC, ABD, the length AB is equal to 5 minus negative 5, which is equal to 10. The length, which is the height h, which I'm going to mark over here as h. If I go up, I'm going to mark this height here as h, is equal to y3 is equal to 2, and therefore area of triangle ABD is equal to half into base into height equals half into base, which is 10, into height, which is 2, which is equal to 10. So the area here is 10 units. According to that, since area of the parallelogram here, which is ACBD, equals 2 times area of triangle ABD. I've actually missed a D over here. I meant to say triangle ABD. Since it's double the area of triangle ABD, we can say, therefore, area of ACBD parallelogram is equal to 20 square units. And with that, we are done with this entire question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.